Today we're going to talk about a four-chambered heart. There's three-chambered hearts and there's two-chambered hearts. Four-chambered hearts are more efficient. The more chambers you got, the more efficiency you have. So why do humans need a four-chambered heart? For a couple of reasons, and they all come down to energy. Number one, we walk on land. And walking on land requires that you support your body weight. That takes energy. Number two, we maintain a body temperature, 98.6, 24 hours a day, 7 days a week. Now think about that. If you were to heat a room in your house to 98.6, 24 hours a day, 7 days a week, what would your energy bill look like? It would be huge, and that would reflect the amount of energy it takes to maintain that temperature. That's how it is with us. We have to produce a lot of energy to support ourselves and to maintain our body temperature. And in order to make that energy, we need an efficient heart. We need to be able to pump that blood, which carries oxygen and it carries glucose to the cells where they can make ATP that eventually can be used to heat our body and to support our body weight. So let's go ahead and talk about the four-chambered heart. And let's start by drawing a diagram. This is going to be a very simplified diagram, and I'm going to draw it just like a heart. So there we go. There's our heart, and I'm going to divide it in half, and I'm going to divide it in half again. So that's going to be our four-chambered heart. Now the next thing we're going to do is at least one blood vessel is going to enter or leave each of the chambers. And these are the four chambers right here. So I'm going to make room for a blood vessel here. I'm going to make another blood vessel over here. Another blood vessel here. Another blood vessel here. And again, this is a simplified diagram, so these blood vessels may not enter or leave at these exact positions. So a simplified diagram. I'm also going to put a valve in here, and I'm going to put a valve in here. So there we go. There's a valve, kind of like a trap door. So now we've got our four-chambered heart. And we've got to go ahead and label the four-chambered heart. So let's go ahead and do that. I'm going to start over here, and I'm going to work my way in this direction. I'm going to start here because the blood is going to return from the body to the right side. This is going to be the right atrium. So let's go ahead and write that down. Right atrium. Now remember, you've got to look at this from the heart's perspective. So if the heart was facing you, this would be its right side. So that's going to be the right atrium. And we've got a blood vessel going into this right atrium. Now, there's going to be two major types of blood vessels, arteries and veins. And there's also capillaries, which we'll talk about later. But arteries carry blood away from the heart. So think about that. Artery A, away, A, from the heart. And veins carry blood to the heart. So the atria are going to receive blood. So veins are going to be coming into the atria. And arteries are going to be leaving the two lower chambers called ventricles. So this is going to be a major vein right here that's going to return blood from the body. And I'm going to use that, I'm going to use blue for that blood returning because this is going to be deoxygenated blood. It's also full of carbon dioxide. And the name of this vein is going to be called the vena cava. Now, in people, there's a superior vena cava and an inferior vena cava. The superior comes from above, the inferior comes from below. Oftentimes, sometimes they both enter separately, sometimes they come together and enter as one. Again, simplified diagram, so I'm going to draw it like this. From the vena cava, this blood is going to go into the right atrium, where it's going to get stored temporarily. And then from there, it's going to get pumped into the right ventricle. Let me go ahead and I'll use black to write that. The right ventricle. Now, before we can get into this right ventricle, we've got to go through a valve. And you're looking at this valve sideways. But if you were to look at this valve straight on, we would divide it up into thirds. It's got 3 cusps or leaflets. So we're going to call it, let's say 3 cusps. We're going to call it a tricuspid valve because it's got 3 cusps or leaflets. And that valve is going to allow blood to come in here, and when the right ventricle contracts, this valve is going to close and prevent blood from leaking back into the right atrium. From the right ventricle, this blood's going to get pumped to the lungs. And that makes sense because we've got deoxygenated blood here, and we need to oxygenate it. So the next place we want it to go is to the lungs. And again, this is going to be from the body up here, but to the lungs. Now we've got another vessel here, and we know it's an artery because it's taking blood away from the heart. So it's going to be an artery, and that artery is going to the lungs. So another word that means lungs is pulmonary. Pulmonary. So this is going to be the pulmonary artery. The pulmonary artery. And then our blood is going to go to the lungs, it's going to get oxygenated, and it's going to come back to the left side of the heart. So here's the blood coming back to the left side of the heart. This blood is going to be from the lungs. Nice, fresh, oxygenated blood. And remember, blood returns via veins. So this is a vein here, and it's returning from the lungs. So we're going to call it the pulmonary vein. So I'm going to go ahead and write that. That's going to be the pulmonary vein. And our blood's going to go into the left atrium. So let's go ahead and write that down. Left atrium. Again, the blood gets stored temporarily, and then it's going to get pumped into the left ventricle. Now, before that happens, it's got to go through another valve. And this valve is going to be a little bit different than this valve. Remember, we're looking at it sideways here, but if we were to look at it head on, it would have 2 cusps or 2 leaflets. And because of that, we're going to call it the bicuspid valve. It also has another popular name, mitral valve. And then from there, we're going to go into the left ventricle. Now, this left ventricle is the most muscular ventricle of the heart. And the reason is, this left ventricle has to pump this blood to the entire body. It's got to go to the entire body. And I'm going to write that down here, to body. So it's got to be very strong. It's got to generate a high pressure to pump that blood to the entire body. Remember, these others, look here, the blood's coming back. It's under a very low pressure here. This atrium only has to pump the blood right next door to the right ventricle. The right ventricle pumps the blood to the lungs, which surround the heart. Not too far there either. The left atrium just has to pump the blood to the left ventricle. But this left ventricle's got to pump the blood to the entire body. So that's going to require a very muscular chamber. And then this blood gets pumped to the body via the biggest blood vessel in the body. And the biggest blood vessel in the body, and this is an artery because it's carrying blood away from the heart, is going to be called the aorta. Now this aorta actually comes out near the top of the heart, comes around and goes down the front of the spine, and then it splits or bifurcates and goes down each one of the lower extremities. Now let's go ahead and orient ourselves just a little bit. The top part of the heart is going to be called the base. And that's where a lot of the blood vessels enter and leave the heart. And the bottom part of the heart, kind of a point here, is going to be called the apex. The apex. Now let's go ahead and talk a little bit about the heart here. First of all, let's talk about the valves. What if one of these valves doesn't close properly? When you go to a doctor, they take a stethoscope and they listen in different places around your chest. What are they listening for? A couple different things, but one of the things they're listening for is to see if these valves are closing properly. See if they're snapping shut, nice and quick and crisp. And if they do, they make a nice sharp sound. And that's how it should sound. If this valve doesn't close properly, and the sound is a little elongated, then that's called a heart murmur. It can be due to lots of different things, but one of the things it can be due to is the valve not closing properly. So let's go ahead and write that down. A heart murmur. And one of the things it can be due to is improper closure of valves. Now, that can be mild or it can be severe. Now, if this valve doesn't close properly, sometimes blood can actually leak back. When this ventricle contracts, blood can actually leak back. In that case, it's called regurgitation. And that's when blood leaks back. A regurgitation. And again, that can be very mild, where you really have no symptoms at all, or it can be very severe, where you got chest pains and you got to get that replaced. Now, of the two valves, and there's actually more valves than that in the heart, but of these two major valves, which one is more likely to dysfunction? It's going to actually be this guy over here. And the reason is pressure. Pressure difference, actually. Think about that. This blood is coming from the lungs here. That blood is under very low pressure when it comes from the lungs. So this is a very low pressure chamber, and here is a chamber that's under the highest pressure in the body. So you got extremely low pressure, extremely high pressure. That's a huge difference in pressure. That puts a lot of strain on that particular valve. And for that reason, this valve is going to dysfunction more than any of the other valves. If we take a look over here, this valve, this chamber here is under low pressure. And this one's under slightly higher pressure, but still really pumping the blood to the lungs, not too far away. So the pressures aren't too different. The difference in pressure is not that much here, where the difference in pressure here, very great. And for that reason, this valve tends to dysfunction a little bit more than this valve over here. Now we've also got this partition right down the middle here, separating the left and right halves of the heart. Now in a three-chambered heart, you don't have that partition, and you get a little bit of mixing of oxygenated and deoxygenated blood. And that's okay if you're an amphibian, or maybe even a reptile, because they're not that active. However, and they don't maintain a body temperature either. However, if you need more efficiency, you need a partition separating the blood so they don't mix at all. That's going to increase the efficiency. So this little partition is going to be called a septum. And the last thing I want to talk about is you have some nerves in the upper part of the right chamber, the right atrium. Let's draw it like this. In real life, these nerves are microscopic. You're not really going to see them, especially on dissection. You're not going to see them. But you've got a concentration of nerves there. And this concentration of nerves actually sets the pace or rhythm of the heartbeat. So for that reason, we're going to call these nerves the pacemaker. And you've got a real pacemaker in there. These nerves are supposed to fire a little less than every second. And there's nerves that come off of here, and they actually go down and they wind around the ventricles. Some of these nerves are called Purkinje fibers. But anyhow, this is where the main pacemaker is located, up here. And it sets the pace or the rhythm of the heart. Now when you get older, just like a wire, if you use a wire a lot in your house, sometimes these wires can begin to wear out. You get to 70, 80, 90. Sometimes they don't fire like they should. And you end up with a little arrhythmia, irregular heartbeat. Or you might end up where the atria actually, instead of fully contracting, kind of quiver a bit or flutter. And then the blood doesn't get pumped as well as it should. And what they do then is they're going to have to actually put an artificial pacemaker in and set the pace of that heart a little bit better. So sometimes that happens. And that's going to be it for the four-chambered heart.